Hello, and welcome to a little video about the Unit 4 test review. Let's get started. First, we're going to solve some equations and then some inequalities. Remember, when we're solving equations and inequalities, our goal is to get x by itself, and we do that by performing opposite operations. All right, number 1. Let's draw a line down the middle, down the equal sign. Remember, our goal is to get x by itself. So let's start by adding 7 to both sides. I'm adding 7 to undo the subtracting on the left. So now I have 9x equals 0. 9x is 9 times x. We're going to undo 9 times x by dividing 9 on both sides. 9 divided by 9 is 1. That's why that works. X equals 0. Fantastic. Don't be afraid of 0. Number 2. While I'm drawing the line at number 2, you probably notice it's a little different. You see how it has 2 x's on the left? Let's combine those. These are like terms. Negative 15x plus 5x is negative 10x. And everything else stays the same. Our goal is to get x by itself. What should we do to both sides? Let's subtract 21 to undo plus 21. We've got negative 10x equals negative 30. Subtracting 21 worked because 21 minus 21 is 0. See? 0 is nice. What's the last step here? The last step is to divide both sides by negative 10. Now it's tempting to say we add 10 because there's a minus there, but negative 10x is negative 10 times x. Negative 10 divided by negative 10 is 1, so we have x equals 3. Number 3. I know it has a fraction, but don't worry, it's not too bad. We still need to get x by itself, so let's start by undoing minus 7 by adding 7 to both sides. On the left side, all we have now is 3 over 4x. 14 plus 7 is 21. Fractions. What operation are they? Are they adding, subtracting, multiplying, or dividing? They're division. So we're going to undo them by multiplying. We're going to multiply both sides by the fraction flipped upside down. And I'll prove to you why this works. When we multiply fractions, we go straight across. So, on the left, we get 12 over 12 for our fraction. On the right side, 21 times 4 over 3 is 28. Then I'm just going to simplify it a bit further because 12 divided by 12 is 1. X equals 28. Number 4. Ooh, we got x's on both sides. So we need to think about how are we going to move our x's to the left. I always prefer my x's on the left, so that's how I like teaching it. Of course, you can move your x's to the right, but I'm making this video, so I get to choose. So how would I move positive 4x to the left? You would undo a positive with a negative, which is subtracting. So let's subtract 4x to both sides, and I'm doing that because then 4x minus 4x is 0. On the left, 8x minus 4x is 4x, and everything else stays the same. All right, what's next? Let's subtract 6 from both sides to undo plus 6. So we have 4x equals negative 20. And what's our last step? Divide by 4. 4 divided by 4 is 1. That's why that works. X equals negative 5. Let's take a look at 5. As I'm drawing the line down the middle, do you see what's different about number 5? It has parentheses. When we have parentheses, we're going to have to do the distributive property, which is multiplication. We're only distributing the number that is directly glued to the parentheses. So negative 3x stays negative 3x. Negative 5 times x gives us negative 5x. Negative 5 times negative 4 gives us positive 20. And it still equals 28. Okay. Well, what should we do first? Hopefully, you can see that we have two types of x's on the left side. So let's combine them. Negative 3x's minus 5x's is negative 8x's. Everything else stays the same. What should our next step be? Let's subtract 20 to undo plus 20. So we got negative 8x equals 8. One last step. What should it be? Divide both sides by negative 8. So we're left with x equals negative 1. Fantastic. Let's do number 6. In number 6, we have some distributive property to do again. So let's start by drawing the line and distributing. Are we distributing the negative 2x or the negative 4? We're distributing the negative 4, which means the negative 2x stays the negative 2x. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12, and it equals 30. What should we do on the left? Let's combine some like terms. Negative 2x minus 4x is negative 6x, and everything else stays the same. Great. What's next? What should we do? We subtract 12 from both sides. We're undoing the addition. So now we have negative 6x equals 18. All right, what's the last step? What do? Divide by negative 6. Yes. X equals negative 3. Great. So all of these problems that I just did, they all had one solution. We got x's to the left, and then we were able to solve for the answer. We don't always have one solution. Sometimes we have no solution or infinite solution. Now this happens when no solution, we get something that's false, like 5 equals 3. That's not true. Infinite solutions happen when we get something like 5 equals 5. Something true. So let's see in 7 or 8 if we have infinite solutions or no solutions, because we've practiced those one solutions a lot. On the test, they're going to be mixed together. So let's see what happens when we have no solutions or infinite solution. What did that look like? So let's draw a line down the middle. And of course, we've got to start by distributing. I don't like that. Let's undo that. Okay, line down the middle and distributing. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. The other side stays the same. Now, I think I said it before, I like x's on the left. So how would we move negative 2x from the right to the left? Let's do it by adding. Now, when I add 2x to both sides, they actually cancel because negative 2x plus 2x is 0. So I got no x's left over. All I have is that 4 equals negative 3. Absolutely not. This is no solution. Let's take a look at 8. Let's draw the line down the middle and distribute. The left side stays exactly the way it is. We're not doing anything to it yet. On the right, negative 7 times x is negative 7x. Negative 7 times negative 5 is plus 35. Okay. Since I'm leading the lesson, as always, I prefer my x's on the left. So let's move negative 7x to the left by adding 7x to both sides. And they end up canceling. I'm left with 35 equals 35. That's true. We have infinite solutions. All right, so 3 types of solutions. One solution, when x's, as you can see, don't cancel out and we get an answer. No solution when the x's cancel out and we get a false statement. And then infinite solutions when we have the x's cancel out and we get a true statement. Okay, on to the next part. On the next part, we learned inequalities. Let me just adjust that. Perfect. Let's remind ourselves what inequality symbols are. We have x is greater than, and x is greater than or equal to. We have x is less than, and we have x is less than or equal to. Okay, with that in mind, let's write some problems. Admission to the zoo costs $25. Each special exhibit costs $10. You have $135 to spend at the zoo for admissions and exhibits. Express the number of exhibits you can visit as an inequality. Now, my hack for word problems is when it asks you to express or to solve for, that's your unknown, that's your variable, that's your x. So I know that the number of exhibits, that's going to be x. I want to write that down so I don't forget. Okay, now, you have $135 to spend, so we're going to start with that, $135. We need to decide on an inequality symbol. So, $135. Can I spend more money than $135? No, that's all the money we have. So $135 is greater than. It's going to be greater than anything we can spend. Could we spend all of our money? Sure. Or equal to. Now, admission to the zoo costs $25. We have no choice. We must spend it. So that's going to go into the spending. And we want to see each special exhibit. Special exhibits cost $10. We don't know how many we're going to visit, so we're going to call it x. So we've got 10x. Fantastic. Let's do the same thing for number 10. Pauline got $250 for her birthday. She already spent $40. Her plan is to use the money to buy McChickens after school during the school year. Each McChicken costs $1.50. Write an inequality that represents the amount of McChickens she can buy. All right, McChickens are X. Pauline got $250. So let's start with $250. Can Pauline spend more than the $250 that she has? No, that's the greatest amount of money she has. Can she spend all of her money? Sure, or equal to. All right, she already spent $40. So $40, they're gone. They exist on the spending side. Her plan is to use the rest of that money to buy McChickens. So, and we're going to buy McChickens for $1.50 each. So $150, X. All right. Now for the last 4 problems, we're going to solve inequalities, and we're going to graph them on a number line. Solving inequalities is the same process as solving equations, except when we multiply or divide by a negative number, we need to remember to flip our symbol. When we graph our inequalities, we need to remember this. When we have a symbol that is less than or greater than, that's an open circle. If there's an or equal to, it's closed. And of course, we draw arrows. Let's start by solving number 11. Just like in equations, I'm going to draw a line down my symbol, and I'm going to work towards getting x by itself. First, let's subtract 5 from both sides. Oh, I didn't mean to choose that color. Let's try this again. Minus 5, minus 5. I'm doing that to undo the addition. So now I have 6x is greater than 30. And what's our last step here before graphing? Dividing both sides by 6. Good. So we've got that x is greater than 5. I divided by a positive number, so I didn't flip my symbol. Since x is just greater than, 5 is going to get an open circle. Greater than, that's when numbers are getting bigger, and that's happening on the right. So I'm going to draw an arrow going to the right. Okay, number 12. Oops, there we go. Line down the symbol. What should your first step be here? Let's subtract 7 from both sides. We're subtracting 7 to undo positive 7. Opposite of positive is negative. So I've got negative x is less than or equal to 3. X is not by itself yet. We're not done. What invisible number is actually in front of x? It's 1. So there's a negative 1 there. So how do we get negative 1 away from x? What should we do to both sides? Divide. Let's divide both sides by negative 1. Since we're dividing by a negative number, our symbol needs to flip. We've got that x is greater than or equal to negative 3. Negative 3, because we have greater than or equal to, gets a filled in circle. Greater than is to the right, so that's the direction my arrow's pointing. Number 13. Let's do the same thing and draw a line down the symbol. Here, what do we start with? What should we do first? Let's distribute negative 4 times x is negative 4x. Negative 4 times 4 is 16. Okay. What's next? Subtracting 16 from both sides to undo the addition. So now we have, oh, I made a mistake. This isn't positive 16, that's negative 16. So we're actually adding 16 to both sides to undo the subtraction. Boy, am I glad I caught that mistake now before I got further into it. So we've got that negative 4x is greater than negative 28. We've got one last step to do, and what is that? Let's divide both sides by negative 4. Since we're dividing by a negative number, we must flip our symbol. X is less than 7. Since we have a less than symbol, we're going to just put an open circle on 7. Less than is an arrow to the left. Okay, last one. It should be number 14, but I accidentally typed number 8 for some reason. A line down the middle. Let's solve. You know me, I like my x's on the left. How do I move positive 4x to the left? By subtracting 4x from both sides. So now we have negative 6x minus 10 is greater than or equal to negative 16. 2 more steps. What should you do? Let's add 10 first. Negative 6x is greater than or equal to negative 6. And what is that last step? Let's divide both sides by negative 6. And since we're dividing by a negative, we must flip our symbol. X is less than or equal to 1. Okay. 1 gets a nice filled in circle, and less than is to the left, so that's the direction we point our arrow. Okay, that's all of Unit 4. If you have any questions, please make sure to ask myself or whoever else is helping you out with this unit, and have a wonderful rest of whatever day it is for you. Bye!